Hello, I'm Joseph, and this is another video of the Pico W. Now, you see I have a couple of things attached to this. This is the debug probe. You can get this for $12, but then it's shipping and taxes, so it's probably like, I don't know, 18. Um, I got a second one, just trying to get one here quicker, and so I didn't get the one quicker enough. And then I also got a second Pi because I was hoping, just because this has come from Pi Shop US, that it would actually come with the newer generation headers, because it comes with like a little 3-pin header here for the newer generations, but no, it's still the old one. And the only reason I'm bringing that up is because that this debug probe, when it comes with the kit with the wires and stuff, it doesn't come with any of the pins for this. So if you get the Pico W headless with none of the pins, you need to get the pins, and then you also need to do the soldering work to solder the pins, and then it doesn't tell you which colors go to what. You got to look at the diagrams between the bug probe and the Pico to figure out which of these pins go to the built-in little mini pins here, or try to solder to, here, let me open this up here, try to solder to the additional headers to here instead. See if that's going to focus, so that you would match the shapes as it would be there, but I just wanted to go through the actual headers there. So yeah, just a little gotcha there. There's three main features of the Debug Pro. One is that you can write to your Pico without having to constantly unplug it, hold the boot select, and plug it back in. You can do step-through debugging. The problem I have with that is that because I'm using Rust with asynchronous code via Embassy, I actually can't step through any of the code. So it's not very useful. You also have like a limit of like 5 breakpoints. And then the last one is the UART connection that you set up there. Now, that's not a free connection in that you're using pins, obviously, but also you need to set up code. And there's quite a bit of boilerplate code that I had to run through for Rust example. So I'm going to show you something real quick here. So here is the UART mode that I would set up for both pins 0 and pin 1 that you set up on the Raspberry Pi Pico. And then you use the same baud rate as the bug probe is, which is 115200. And one thing I had to change was PIO1 because it was 0. And the reason why I had to change that, which is the programmer in and out interface stuff, is that the Wi-Fi actually uses it. So it's the reason why you still have access to all 40 pins and everything is that this Wi-Fi is using up one of the programmer interfaces that you have. So I think you're limited down to just one. And then all the boilerplate to this is I just chucked it at the bottom of the file for now, and I copied it from um, the Embassy Pico UART demo, and instead I just swapped things to PIO was 0, and then added some custom buffer stuff for my own like little write commands. But I can now read and write from the serial, and then you can use something like PuTTY to connect to COM whatever. This is COM4, and I can now whenever I go to my Hello World example, I have it right to my console. So while I can't step through my code, I can just do print debugging and just print to this. So fairly straightforward with that. Now, the way I write to that is very simple too. I just have let's see where I have this at. I shouldn't make the code bigger, but I just do a UART TX, which is transfer, write the bytes, await, and unwrap. If I didn't have unwrap here, I'd need to change how all this works here. So that was that. And then I started to work on the SD card. Now, a big kind of pain point for the SD card was one, I had to use some MicroPython tutorial, and that was wrong because it was using SPI 0, but using the pins for SPI 1 interface. So wasn't translating over to Rust at all. I don't know how they got it to work in the first place. And so the pins were completely different, and I literally went to every possible SPI pin, plugged them all around, and it still was not working. I can get the card reader to run, but the actual SD card wasn't working. I started all these different types of SD cards, setting the different block sizes from 512 to 1024 to 4K. Nothing seemed to work. It kept getting it stuck in like a timeout, and I tried to increase the timeout. No matter how long I had the timeout, it just didn't work. And it boiled down to something very stupid, which was this little red cord here. That's the power. This is going to VBus right now. VBus is literally whatever power is coming from USB. So this is 5 volts. So it takes in 5 volts. And then the SD card specifically has a voltage down thing that converts it back down to 3.3. So I had this originally plugged into the 3 volts or 3.3 volts GPIO pin, or pin at least, and it wasn't working. As soon as I switched it to here, everything started to work, with the exception of in Rust. When you set this up, you need to specify some DMA or DMA channels, one for transfer and one for receive. This is technically should be automatic. I don't know how to do this automatically. So you need to specify these channels. And if you use other ones, you kind of have to know which ones you're already using and not use those as well. So yeah, I finally got it to work. And so I was working on a thing here to go ahead and read from the SD card. So here we go. Hello from SD card. That's reading from the SD card. To kind of show you what that is. It's literally just a one command that I've set up. Now I had to do the work to get all this to happen and stuff like that, and getting the SD card reader set up with the specific pins. But I can read from a file now, and I can also list a directory of files. So this is the root directory of the SD card. And then I'm working on like an edit. Right now it locks it up, which is why I was trying to get the debug probe set up so I can figure out what's happening next. But if I go to this, it'll lock up the Pico. But basically, I can, get the list of directories, write it out to something here. And then I have another thing I've worked on was JSON Web Tokens. And it's not to use it for AJAX requests specifically, but actually put inside of a cookie. Just for some kind of walkthrough on what a JSON Web Token is that it'll basically take your session data that you would store on a server, put it inside of encode it. That's not really this type of thing. Encoded string, and the string is broken into three primary steps. The first part here is the encoding practice that you use to encode your payload. So this is the header, the payload, and then the signature. So this is not encrypted right now. I don't have a way to encrypt it because encryption doesn't seem to work on the Pico specifically. Instead, this is just a base64 URL encode. And so all of this is base64 URL code. This payload you can decrypt and you can see the data inside of it. So obviously you don't want to put like passwords and stuff inside of there. And so when you decrypt, when you get all this information, you put it together, you have the signature key to verify that they didn't change it. And if you try to change it, you have to change the signature key to match the private key that you have here. So here's like a private key I have that's also URL base64 or URL encoded, not base64 encoded. And then I can write these to a disk or an SD card and so on and so forth. So I started to do all this. I have a way to verify it, and I just haven't put it into a cookie yet. And then I still got to work on the database here to get the key value store to actually write to database, or sorry, write to the SD card. And then the other two parts, last two parts, is I do have the ability to do for loops now. So I have an example for loop here. Where is it? So I have this bit where I say for person and people with the name, and you say person.name, person.age, person. There's nothing else there, but then you end it with the for loop. And then the way that you activate is you set up a static dictionary that I programmed, that you pass in that data, that you can pass that into the for loop processor, and you specify person, people, and that does the work behind all that. And the last part was I got multi-part working. I just don't have files currently to be uploaded to the server for that. So it's now able to take in a boundary for multi-part and parse it out and get the individual fields that you'll pass into it. And I currently don't pass any headers from these fields because each of the boundaries do have headers. Like sometimes they'll have content length or something like the form data with the name, stuff like that. So if you had anything on there specifically, I don't have that passing through just yet, but you kind of get the idea. And that's really it. There's not really much else to show. There's just a lot of kind of fighting back and forth with the SD card, and then trying to get the debug probe to work with step through debugging to find out that that doesn't work, and that I need to set up a custom debugger with Rust and Embassy to be able to try to debug it. But as long as I get my kind of serial print debug stuff, I'm good to go for now because I can figure out what the issue is for my next one, which was actually being able to edit the SD card data for now so I can put in stuff here. So like if I click it, it locks up because there's something going on. And while I can't step through the code, I can just print a bunch of stuff while that's happening.